Okay, so today we're going to be doing 10-3 operations with radical expressions. The first example we're going through is we're going to be combining like radicals. So if I look here, I've got a radical 2, or a square root of 2, and over here I have a square root of 2. Alright, if I were to do this problem, let's kind of go backtrack a little bit on something you already know. If I were to just have x plus 3x, and I asked you to combine like terms, how many x's would you have here? Okay, how many x's would you have here? We have an invisible 1 in front of this x. So there's two terms, but there's 3 x's here and 1 x here. So there's 4 x's. Okay, so we're going to think of our radicals as kind of like x's. I have 1 radical here, 1 radical 2 here, and 3 radical 2 here. How many radical 2's do I have? I have 4 radical 2's. That's my answer. Okay, on this one I have radical 5's. There's a radical 5 here and a radical 5 here. I have a negative 3 radical 5 and a negative 7 radical 5. How many radical 5's do I have? Negative 3 and a negative 4. Add those together, you get negative 7 radical 5. That's my answer. Now here I have a radical 10. There's 1 radical 10 here, and there's negative 5 radical 10's here. How many radical 10's do I have? Well, 1 and a negative 5 is a negative 4 radical 10. That's my answer here. Alright, now we're going to go down to number 4. New directions or new example. We're going to simplify to combine radicals like radicals. Oop, the directions are not typed right. Let me fix it real quick. Okay, I fixed it. So the directions are simplifying to combine like radicals, to put the radicals out. Okay, so let's look at number 4. We have 7 radical 3, and over here we have a radical 12. We don't have like radicals. This is a radical 3 and that's a radical 12. So right here I'm going to look at the radical 3. Can I simplify that at all? I can't. So I'm going to go ahead and just keep that. 7 radical 3. But now here, can I simplify radical 12 or square root of 12? There's a perfect square within here. There's a 4. So square root of 4 and a square root of 3. Because 4 times 3 is 12 and they're both radicals. So I can simplify this to 2. So square root of 4 is 2. I keep my radical 3. Over here I had a 7 radical 3. I keep my subtraction sign. That's from the original problem. So now I have 7 radical 3 and a negative 2 radical 3. How many radical 3's do I have? I have a 5 radical 3. Because 7 minus 2 is 5, and that's my answer choice. Alright, let's look at the next one. Now I've got a 20, radical 20, and a radical 5. Okay, I can't do anything with this radical 5, so I'm going to keep that. 2 radical 5. But over here, can I simplify this radical 20? It has a perfect square in it of a radical 4 and a radical 5, because 5 times 4 is 20. They're both radicals, and I'm going to keep my 3. So now I've got my 3. Square root of 4 is 2. This is multiplication, and I have a radical 5. I'm going to multiply because numbers multiply with numbers. So 3 times 2 is 6. 6 radical 5. Plus, I'm going to keep that and bring it down to radical 5. Okay, now I have like terms. I have a radical 5 here and a radical 5 here, so now I'm just going to add the numbers. 6 plus 2 is 8 radical 5. And that's my answer for number 5. Okay, number 6. I look and I say, okay, can't do anything with this 3 radical 3. I keep my negative 2. Can I now simplify that? I'm going to kind of do it over here to the side. Can I do a radical 9 and a radical 3? What's the square root of 9? It's 3, but remember, this is multiplication, so I need to put a little multiplication sign right there. Radical 3. So at this one, I didn't do anything with this. I keep 3 radical 3 here. I keep my negative sign because negative 2 times 3 is negative 6, and I've got my radical 3. So now I have a 3 and a negative 6. Put those positive 3 and negative 6 together, I get a negative 3 radical 3, because now I combine the like terms of radical 3. And that's my answer. Okay, next section we're going to do distributive, using distributive properties. So now we're going to do some multiplication. Alright, so now I'm going to multiply. Remember, radicals can multiply with radicals, and numbers multiply with numbers. So I've got a radical 3, I can multiply it with another radical. So 3 times 6 is radical 18. And remember, radical is just another name for square root. And then I've got a radical 3 times a number that is 7. I cannot combine those together or multiply them together, so I'm just going to rewrite them as a pair. Okay, now I can't combine anything. I'm going to see if I can break this down and take out another perfect square out of here. I've got radical 9, or square root of 9, and square root of 2. That's a perfect square, so square root of 9 is 3, radical 2. I still have this positive 7 radical 3. Can I put the radical 3 and the 2 together? Can I add them together? I cannot. I can't do any more with this problem, so I'm all finished. Okay, let's look at number 8. Again, it's a distributive property, so we're going to multiply radicals, multiply with radicals. So 5 times 5 is 25. A times A is A squared, but it's all under a radical symbol. And now we've got square root of 5a, or radical 5a times 3. We cannot combine the 3 and the 5 together, so we just have to put the 3 on the outside, the 5a under the radical symbol. Okay, now, can I simplify? And can I take the square root of 25, which is 5, and the square root of a squared? Remember, that cancels out and it's just an a. Over here I have a positive 3 radical 5a. Okay, can I combine the 5a here and that 5a here? I cannot, because this is under a radical symbol and they're not the same. This is a number and a letter. This is a radical 5a. So that's all I can do with that problem. So I'm all done there. Okay. The next example. The next example is using the FOIL method to simplify radicals. Alright, so I'm going to move down a little bit. Okay, hopefully I have enough space. I'm going to use a FOIL method, and I'm going to multiply this term, with the first term. That's our f. So I'll kind of maybe label this for you. So this term with the first term. So radical 5 and radical 5 is radical 25. Okay, then I'm going to multiply this term with the outer term. And this is where they get the O. So radical 5 and a radical 15 is positive radical 75. Okay, then we got the next part, and I'm going to change my color. Go with green. We're going to multiply this term with the inner term, and that's where they get the I. And it's the whole thing, it's with that 2 also. So we got negative 2 radical 15 times radical 5. So I keep the negative 2. 15 times 2, we already did that, which is 75, and it's under the radical symbol. And then the last term, I should have left us more room, is going to be this one, and I'm going to kind of go around here and multiply there. So that is where they get the, the L, the last term. So it's this multiplied with that. So I've got, and actually, I'm going to go ahead and start this again because I think that made it a little bit confusing. Let me do this. Okay, so we're okay with the red. We've got, I'm going to move it down here. We've got square root of 25. And then the blue is our outer term. So we've got a positive square root of 75. Okay, then I'm going to go to my green. It's this times that, and I lost my parentheses there. This is where they've got the I, which is the inner term. So I'm going to multiply this times that. I lost my parentheses there, sorry. So this times that, and that would be negative 2 radical 75. And then the next one, we'll do it in gray. It's this times that one. That's better. Now you can kind of see the L. So we've got negative 2, and 15 times 15 is 225. Okay, so now I'm going to go ahead and do the math. We'll go back to our black. Okay, square root of 25 is 5. We've got these two radical 75s. I've got a positive 1 and a negative 2, so I have a negative square root of 75. And then I'm going to take and keep my negative 2, but what's the square root of 225? And it is 15. And remember, these are multiplication problems right here. Alright, so now, so now I've got, I'm going to multiply. I've got my 5. I've got my negative 75, but I have it under a radical symbol still. And then I'm going to multiply these together. So it's negative 30. Okay, I'm going to erase my problem I wrote. I just didn't leave myself enough space. Okay, now we've got numbers. I've got a 5 and I have a negative 30. Numbers will go together, so I got a negative 25. But I still have this negative radical 75. Okay, I'm going to go down, and I'm going to look at 75 and ask myself, is there a perfect square within 75? And there is. I'm going to keep my negative 25. I keep my negative sign here, but I'm going to break this down to the square root of 25, square root of 3, because 25 times 3 is 75. So I have my negative 25. Square root of 25 is 5. I keep my negative sign, radical 3. Remember, these two are connected. It's a one term because it's negative 5 times radical 3. So I cannot combine the negative 5 and the negative 25 together. At this point, I am all finished. Okay, that's using the FOIL method. So I'm going to do one more for you. This time, hopefully, a little bit smoother. I'm going to give myself plenty of space so we can kind of make sure you're understanding where the FOIL method comes in. Alright. Okay, we are going to, again, use the FOIL method, and I'm going to go ahead and label everything again. So it's going to be this terms times the first. This is the F. So now we've got a 2, but there's no number to multiply with it. But now we have a 6 times 6. It's going to be radical 36. The next one, I'm going to take this same term and multiply with the outer term. That's the O in FOIL. Okay, so now I've got 2 times negative 5 is negative 10 because numbers multiply with numbers. Now I've got 6 times 3 is radical 18. Okay, then I've got Okay, now I've got my next one, and I'm going to go ahead and put it as a green. I'm going to multiply this and that. That is my inner term. That's an I. So you take this inside and you multiply it with the outside on that side. So we've got a positive 3, and then 6 times 3 is radical 18. Okay, I'm giving myself a little bit more space because I didn't give myself space again. Okay, so I'm at that point, and then the last one, I will use the gray. It's going to be that this term multiply the last term. That's where the L comes from. So F-O-I-L, FOIL. So we've got 3 and a negative 5 is negative 15, and then 3 times 3 is 9, so square root of 9. Okay, now I'm going to go ahead, I'm going to go back to my black color and do the math here. I keep the 2. What's the square root of 36? Is 6. So this becomes 2 times 6 because I simplified that. Then I have a negative 10 radical 18 and a positive 3 radical 18. So I have a negative 7 radical 18. And then I have a negative 15, and I'm going to multiply it with the square root of 9, which is 3. Okay, so I'm at that point. Okay, so now let me change my color. Let's do green. So now we're going to multiply this. We get 6 times 2, which is 12. And I have negative 7 radical 18 still for now. And then I have negative 15 times 3 is negative 45. Okay, let's go ahead and combine the numbers. So here's one number, and here's another number. Can combine those together. 45 minus 12 is 33, and it's going to be a negative 33. Okay, now I look at 18, square root of 18. Can I simplify that? And I can. I can simplify this by taking, going to keep the negative 7, make this a radical 9 and a radical 2. I keep my negative 33, I keep my negative 7, I simplify square root of 9, which is 3, and I have a square root of 2 left. Okay, I keep my negative 33, I say negative 7 times 3 is negative 21, and it's connected to radical 2. Okay, I don't have any more radical 2's, I have no more numbers, so right here is my answer. That's my answer for number 10. Okay, we have one more to go. Okay, and the next problem is rationalizing a denominator using the congruence. That means we want to get rid of all the radicals in our denominator. And how you do that is you use the difference of squares formula. We have, this is that. This was A plus B, A minus B is equal to A squared minus B squared, because that's what the formula we're going to use. Okay, if I look at this denominator, I see it has a square root of 5 minus a square root of 2. I want to rationalize it. I'm going to use the difference of squares formula. So I'm going to create an A plus B and an A minus B. Here's my A, and there's my B. So this one's going to be radical 5 plus radical 2. Just doing the opposite of what's here. If I do that to the bottom, I have to do the same thing to the top. So I'm multiplying top and bottom by the opposite sign that's here, but using the same radical symbols. Okay, what I just created here at the bottom was a difference of squares. I just created radical 5 squared minus radical 2 squared. At the top, I have 6 times radical 5 plus radical 2. Okay, when you take the square of a square root, you undo it, so you have a 5 at the bottom. When you take the square of a square root, you undo it, so you have a 2 at the bottom. You also have a minus sign there. Okay, then I'm going to take this one step further. What's 5 minus 2? It's 3. So our denominator is rationalized. Now, I'm going to take this and I'm going to multiply. So 6 times radical 5 is 6 radical 5. And then over here, I'm going to do distributive property. 6 times radical 2 is just a positive 6 radical 2. Okay, at my denominator, I do have 3. So I've got a 6 radical 5 over 3. And then, I'm going to do and plus 6 radical 2. And I'm also going to put that over 3 because I want you to be able to see, and I put it under 2 separate problems, I want you to see that you can cross cancel. 3 will go into 3 once, 3 will go into 6 twice, 3 will go into 3 once, 3 will go into 6 twice. And at the top I have 2 radical 5 plus 2 radical 2. And so at this point I could stop, or if I don't see that as an answer choice, if I was doing a multiple choice, I might look and say, did they maybe take the 2 out and put a parentheses here and write it like this? Because both answers are correct. It could be this or this depending on your answer choice. Okay, so that is number 11. Let's do one more and then we'll be done with 10.3. Alright, so I look at this and I look and I say I want to get rid of the radical symbols in my denominator. So if this is a plus, I'm going to multiply top and bottom by radical 10 minus radical 8. I keep my negative, and I got to do the same thing to the top, radical 10 minus radical 8. Okay, you can skip this part right here. You can skip writing this section right here. If you just remember that you're going to take what's inside the square root symbol, the 10, and it's going to be 10, and it's always minus 8. We'll just go ahead and skip that part. The top is going to be multiplication, so it's negative 4 times radical 10 minus radical 8. Okay, at the bottom of our fraction we have 10 minus 8 is 2. We rationalize our denominator. We'll go ahead and do our distributive property now. We have negative 4 times radical 10, and then we have negative, and negative is positive 4 radical 8. Okay, and last time I wrote it as 2 separate fractions, but I just wanted to make a point. I wanted you to see what I was doing. So at this point I can look at 2. Will 2 go into 4? It'll go in 2 times. Will 2 go into this 4? 2 times. So therefore I have negative 2 radical 10 plus 2 radical 8. And I look at my answer and I look to see if it can possibly be factored out any further. I look at my 10 and I say, okay, is there any perfect square within 10? And there's not, so I'm just going to go ahead and keep negative 2 radical 10. But then I look at 8. Is there a perfect square within 8? And there is. I'm going to keep the 2. I've got a radical 4 and a radical 2. So now I've got negative 2 radical 10, and then I have 2 times 2 radical 2, which becomes 4 radical 2. I still have my negative 2 radical 10. I have my positive sign there. And then I look and see if it can be simplified any further, and it can't. So therefore is my final answer. So you can keep simplifying and simplifying until you can go no further. Alright, so that was quite a bit for 10-3.